Hello everybody, how are you? Welcome to EduSure's 50 days 50 topic course of UGC NET JRF 2025. And today is Mathematics Day and I will be discussing sets and its operations from your course. Okay, so we all have encountered the term sets in our daily life. For example, a sofa set, a dining set, a jewelry set, etc. So what is a set? In a layman's language, a set is a collection of similar kind of objects. So in mathematics, what is a set? A set is a collection of, generally, it is a collection of numbers satisfying a common property. Satisfying a common property. Okay. For example, I say, let S be the set of all natural numbers less than 10. Less than 10. So what is the common property of these numbers? They are all natural numbers. That means they are all counting numbers and they are less than 10. So how do I write set in a mathematical notation? The elements of the set, that means the members of the set, are written inside curly brackets only. Please do not use any other kind of brackets. Not allowed. Not allowed. Only curly brackets. So we have natural numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. This is this particular set. Okay. Now another example is that suppose we have a class of 5 students. Okay. And they give an economics test. Okay. And their scores are 10, 12, 12, 8, 6. So the set consisting of the marks will be 10, 12, 8, 6. Remember one thing, here 12 is repeated twice, but it will only be written once in a set. That means one element cannot be repeated more than one time in a particular set, no matter how the frequency is and how much the frequency is. Maybe it is repeated 100 times, but you will write it only once inside the set. Okay. Now, certain notation. Now, if I say 10 belongs to set, what will I write? 10 belongs to S. This is a notation. This is called belongs to. Okay. For example, I say 7 does not belong to S. 7 does not belong to S. The notation is does not belong to. Okay. So this is belongs to and this is does not belong to. And you have to represent the elements inside curly brackets. All right. Now, a set is represented in two kind of forms. Okay. So what is a representation of sets? One is a roster form, and one is called set builder form. Set builder form, that means we have to use words or mathematical symbols. Okay. So what is a roster form? In roster form, you write each element, explicitly inside the set. Okay. So for example, what was our first set? Our first set was the set of natural numbers less than 10. Okay, so this is the roster form. I have written each and every element. Okay, obviously I don't want to write all these, so I'll just separate them by commas. That is acceptable. But for example, you want to write it in set builder form. That means you have to use language. So how do you write? S consists of all those X such that, now these two dots mean such that X is a natural number and X is less than 10. So what you are doing, you're not writing these elements explicitly, but you are using words or codes for that. Now, how is the set builder form useful? You can say, I don't want set builder form. I just want to write this. But suppose a set contains 1,000 elements. So for example, they say S1 is the set of all even numbers between 1 and 200. Okay. So you will not keep on writing all the even numbers 2, 4, 6, 8 and so on. What will you write? That will be very inconvenient for you. So what is the set builder form? You can say x such that x belongs to the set of natural numbers. Okay. Or you can say x is equal to 2n, where n belongs to n, and 1 less than n less than 100. Okay, so there is no need to specify this. You are writing that x is 2 times some natural number, and that natural number is between 1 and 100. Obviously, when I put n equals to 2, I'll get, you know, so, but I want what? I want 2 also, so I'll be putting an equal to sign over here. So when I put n equals to 1, I'll get 2. And when I'll put n equals to 99, I'll get 198, and that's it. So I will not be including 100 over here, but 1 I will be including. Okay. So set of all natural numbers between 1 and 200, this is how we write the set builder form. So this is how we represent set. One is using roster form, another is using set builder form. All right. Now the next concept is subsets. Okay. So subsets. So A is called a subset of B if either A is equal to B or A is strictly inside B. What does it mean? So suppose we have a set A equals to 1, 2, 3, 4. And we have another set which is 1, 2, 3, 4, 5, 6. So if you make B, you can see that A is strictly inside it. How? Because A has 1, 2, 3, 4, and these two elements 5, 6 are strictly in B only, not in A. Understood? So this is an example of this. But we can use this because there is an OR involved. So what do you mean by A is a subset of B? This is a subset of. Okay, so A is a subset of B if either A is equal to B, if both the sets are same, or A is strictly inside B. Or mathematically, this is like in a layman's language, mathematically we can say that A is a subset of B if X belongs to A implies X belongs to B. Okay, this means implies. Okay, that means if you pick an element in A, it has to be inside B. That is what is the meaning of this particular statement. So we also have a statement which is known as superset. So what is superset? So this is like A is a subset of B, is can be equivalent. This is known as equivalent. Can be equivalently written as B is a superset of A. So is a superset of A. So it is equivalent to saying that A is a subset of B and so on. All right. So this is about subset. Now, what is an empty set? What is an empty set or a null set? It is denoted as this or curly brackets without anything. That means a set containing no elements. Okay, that is what is called an empty set or a null set. All right, now there are, how do we compare sets? How do we compare sets? So, how do we compare sets? So, we say A and B are equal if they have exactly same elements. That means if I say A is equal to 1, 2, 3, 4, 5, and if I say B is the set of all natural numbers less than or equal to 5. So you can see that both the sets will be same. This will also contain 1, 2, 3, 4, 5. That means the way of saying may be different, but they will have exactly same elements. Okay. Now two sets are called equivalent. Two sets are called equivalent if they have same number of elements. That means if A is 1, 2, 3, 4, 5, and if B is A, B, C, D, E, so number of elements in A is equal to 5. Number of elements in B is also equal to 5. That means they are equivalent sets, but they are not equal sets because the elements are different. They look different, but the number of elements are same in both the sets. So this is how you compare two sets. Okay. Now, cardinality of a set, the next topic, cardinality of a set. Cardinality of a set. So what is cardinality of a set? Cardinality of a set is the number of elements in it. Okay. So for example, if A is equal to 1, 2, so the cardinality NA is equal to 2. This is called cardinality of A, number of elements. So there are two type of sets, finite sets and infinite sets. So finite set example, A equals to 1, 2. And infinite set example, set of natural numbers 1, 2, 3. So obviously, I cannot count the cardinality of natural numbers. I don't know how many natural numbers are there. So the cardinality of such sets is infinite. We say that the cardinality is infinite. So generally, cardinality is used in the context of finite sets. All right. Now, the next thing is operations on sets. Operations on sets. Okay. So the first operation is A union B. This means union. It is also, this operation is also called OR. So A union B contains elements that are either in A or in B. Okay. Second, A intersection. So this is intersection and this is also known as AND. So this contains elements that are common to A and B. Okay. Number 3, A complement. This is this, or it is also written as AC. So this is called complement of A. So complement of A contains all those elements which are not in A. Now, which elements are you talking about which are not in A? So what do you mean by not in A? Not in A means they must be in some universal set. Okay. So that means universal set minus A. Okay. Now, fourth, A minus B. This is called difference. So what is A minus B? Remove elements of B from A. Okay. So now I will be discussing these operations one by one with you people. So what are these operations? So for example, my universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My set A is 1, 2, 3, 4, 5, 6. My set B is 1, 3, 5, 7, 9, 10. First, A union B. That means I have to combine the elements. So 1, 2, 3, 4, 5, 6, 7, 9, 10. That means I will be taking the elements which are either in A or in B or in both. But I will be counting them exactly once. For example, I will not count 3 twice. So 1, 2, 3, 4, 5, 6, okay, 7, 9, 10. Second, A intersection B. So the common elements 1, 3, 5. 1, 3, 5. Number 3, complement of A. Complement of A, that means the elements which are not in A, but in the universal set. So this is my universal set. That means it is my entire universe. I cannot go out of this. I only have these 10 numbers. So what is A complement in that case? 7, 8, 9, 10. Similarly, what is B complement? B complement is 2, 4, 6, 8. All right. Number 4, A minus B. A minus B means I have to remove the elements of B from A. So A has 1, 2, 3, 4, 5, 6. And what are the common elements? 1, 3, 5. So I will be left with 2, 4, 6. Similarly, let's do B minus A. So B minus A means I have to remove the elements of A from B. So again, remove the common elements 7, 9, 10. These are called operations on sets. Now we discuss power set, PA. This is called power set of a set A. Okay. This is nothing. This is the set of all subsets of A. Okay. So for example, if A is, okay, so if A is singleton 1, that means there is only one element. So what are the possible subsets? The empty set or the set itself. So what is the number of elements? 2, which is nothing but 2 power 1. And what is the cardinality of A? What is the number of elements in A? 1. Example, A is equal to 1, 2. So what are the subsets? Empty sets, the whole set, 1 and 2. Okay. So what is the cardinality of A? 2. And what is the number of subsets? What is the cardinality of the power set? 2 power 2. Okay. So you can continue like this and observe a thing. So what is the observation? The observation is this, that if the cardinality of a set is P, then the cardinality of its power sets, that means the number of subsets will be 2 power P. Okay, this is a very, very important result. Okay, also, what is a proper subset? So you can see that when I'm counting the subsets of these sets, I'm taking the whole set also as a subset. So I've taken one here, I've taken 1, 2 here. So if I talk about proper subsets, so proper subsets will not contain the whole set. Okay. So what is the number of proper subsets? What is the number of proper subsets? So you count the total number of subsets that are possible and subtract one from it, because I have taken the complete set also as a subset. So I will have to remove that particular thing also. So this is regarding power set. So remember that when you are calculating the power sets, you have to put these sets inside one more set of curly brackets, because that is a set in itself. Okay. All right. So the next thing that we should be doing is counting. counting. So what do you mean by counting? So for example, this is your universal set and this is your set A and this is your set B. Okay. So if you want to count the number of elements in A union B, okay, so you will count the elements in A, C, then you will count the elements in B. Okay. And then you can see that while counting the elements of A and B, you have counted this intersection twice. So I will be subtracting it. Okay. First. Similarly, if you have three sets A, B, and C. So the number of elements in A union B union C is number of elements in A plus number of elements in B plus number of elements in C. Then you will be subtracting all the intersections. Okay, taken two at a time. But while removing all the intersection taken two at a time, this portion is removed twice. So you will have to count it once. Okay, so this is the counting principle for three sets and this is the counting principle for two sets. Now these questions are very, very useful to deal with counting problems and these counting problems are very common in a UGC NET exam.